Good morning. My name is Bhuvana and I am here to present on the topic electrical safety and medical equipment. Let's look into the contents. It consists of medical engineering and electrical safety, electrical power distribution system, two kinds of grounding, macro shock and micro shock, methods of protection against electrical shock, isolated power system, and rules for medical equipment and electrical safety. Medical engineering and electrical safety. It ensures the highest possible level of medical equipment safety in hospital. It deals with the concept of medicine and biology for healthcare purpose. Electrical safety also refers to the electrical shock protection. So what is the mechanism behind this electrical shock? Electrocution. It refers when a victim is a part of an electrical circuit in which an electrical current can flow and has the ability to harm the victim. So we can also say the electrical shock is equal to the closing of the electrical shock circuit, which is nothing but the current can flow in a closed path. Generally, electric current can affect the human body in three ways. First is through resistive heating, that is, the passage of electric current through conductor produces heat. Next is electrical stimulation of nerve and muscle. And the third one is electrochemical burns, which are caused especially due to the DC current. So, the electrical power distribution system. Due to some technical reasons, the neutral point is connected to earth. So, this connection that makes the electrical service as grounded system. So, this is also a key feature for understanding the mechanism of electrical shock. Generally, in a metal body equipment, there are three wires: phase, neutral, and earth. So, this diagram represents the neutral point connection. On the distribution side, we have high voltage power, and on the service side, the power is transmitted. So, it has the line indicates there is a ground connection. Now let's look into the two kinds of grounding or earthing. So one is the grounding of electrical systems, which refers to connecting n lines, that is more number of lines on the service side to the earth due to some technical reasons and for the protection of systems and plants, so that removing the floating of high voltage in the secondary side of the transformer. So this is nothing but it connects the current carrying point to the ground. And next is protective grounding. So this are not intended for carrying current in normal circumstances via the third conductor. For example, the lineman working in the transformer. So this protective grounding prevents those workers from the electrical shock. So how is this shock occurs? So on the supply side, we have a voltage around 220 volts and it is passed through the outlet. And on the consumer side, the current passes through the human body. And if he is grounded, he gets protected from the electrical shock. Next is the leakage currents. So these leakage currents are caused mainly by the stroke capacitance. So stroke capacitance are nothing but the unavoidable and unwanted capacitance exists between the electric component and circuit due to the closeness. Let's look up the difference between the macro shock and micro shock. Macro shock refers to the externally applied current passing through the body. That is, when we look at the diagram, the two point of contacts are on the surface of the body. The current range is about 8 milliampere. In case of micro shock, when we look at the diagram, one point of contact is on the surface of the body and the other is connected to the pacemaker or catheter, which is present in the heart. So here the current range should be less than 100 microamperes. So these are the methods to be followed to get protected against the electrical shock. Firstly, overcurrent protection, and next is protective grounding, and double insulation, low voltage power supply, differential circuit breaker, and isolated power system. Let's look deep into these specified topics. So protective earthing. So this is a simple, efficient and an inexpensive way. So once if this equipment does not go in a safe mode, like power interruption for example, these equipments are referred to as class 1. Double insulation. When we look at the diagram, the live wire and the neutral wire combined together forms the two-core cable. Apart from this, there is an outer casting which consists of insulating plastic, which is the double insulation. So for this, the surfaces which can be contacted are made of non-conductive materials. So this type of equipments are referred to as class 2, and they need not to be earthed as already there is an insulation. Next, low voltage supply. So these are referred to as class 3, and the supplied voltage must be less than 50 volt, and as in the previous way it need not to be earthed. So these are specified in 3 specific cases. For wet areas the voltage should be less than 25 volt. When the body is immersed or skin is immersed in water, the voltage should be less than 12 volts. And if supply is via the transformer, the primary and the secondary line must be galvanically separated so that it currents the current flow. So next is differential circuit breaker. So it is used to compare the current going into the circuit and coming out of the circuit. If this ratio is same, it allows current to pass through. But when it exceeds this condition, or if it is more than 6 milliampere, this circuit breaker gets activated. It is also known as fuse. On the other hand, when we look at GFCI, which is the ground fault current interrupt, it is used for the earth line leakage current. It is one of the oldest technology as well, and it is used to measure the voltage in the earth conductor. Next, which is quite important, that is the isolated power system. So it is used to omit the ground connection on the service side, that is there will be no more grounding. So it is used for the electrical services of various applications in hospital and medical field. So is it 100% isolated? No. So it has certain resistance which is caused by the state capacitance which I have mentioned earlier. And the isolation transformer is also referred to as 1:1 transformer. This provides safety and avoids shock. So what are the applications? So it is a protection against macro shock, but not a protection against micro shock, because it has a related safety level higher, and these are necessary for operation theatres but not in the ICU. So this is the diagram of the isolated power system which will be present in the ground portion of the hospitals. And next are the rules to be followed. So patient to be connected to the common ground through only one grounding pole, and isolation amplifiers to be used for measurements if possible. So what are these isolation amplifiers? They ensure that the isolation of patient from power supply or leakage of current. And if possible, avoid using materials which can be charged electrostatically. Why to use these? Why to avoid these materials? Since there will be an excess flow of electron on the insulating surface. So to be carefully dealing with the electric wires and sockets, and to check them periodically. Sockets are nothing but the electrical devices receiving a plug point. Finally, we have come to the end of the slide. So electricity is very useful if it is safely used, but it would be dangerous if it is not safely used. And electricity can be compared to a knife. Like you can cut things with it properly and safely, but It can hurt by accident or misuse. Thank you.